Okay, Unit 8, Target 5, some notes in case you needed to hear again what we did in class or you were absent. We started off class by deciding what types of triangles these were, classifying them by their sides. So a triangle with no sides that are the same, so no sides congruent, we call that a scalene triangle. We're not going to be focusing on that this target. When we have two sides congruent, or two angles congruent in a triangle, we call that an isosceles triangle. And we will be spending a lot of time in this target on isosceles triangles. And then if we have three sides or three angles congruent, we call that an equilateral triangle. You could also call that equiangular, but equilateral, when you use that term, people know you're talking about the angles and the sides. So for target 5, we're going to look at the equilateral and isosceles triangles. When we did right triangles, we had some vocabulary like legs and hypotenuse. And you had to pay attention that the hypotenuse was always opposite the right angle. For an isosceles triangle, we also have legs. The legs are always going to be the two sides that are congruent to each other. So no matter the orientation of your triangle, a leg of an isosceles triangle is always the two congruent sides. We call the vertex angle the angle that forms those two legs of the isosceles triangle. The vertex angle is always opposite the base. So if the two sides of the triangle are legs that are congruent, the base is the third side of the triangle that is not congruent to the other two. And then the important part that we're going to look at is these base angles at the bottom. One thing we know about an isosceles triangle is that it has two congruent sides. We also know that it has two congruent angles. These angles at the bottom are considered my base angles. Okay? Two angles adjacent to the base. The base angles theorem is the theorem we're looking at today. It says if two sides of a triangle are congruent, so for example AB and AC are congruent, then the angles opposite them or across from them are also congruent. So angle B and angle C would be congruent. The converse is also true. If you know the two angles are congruent, then you can use the two sides as congruent. So here's a basic example. Given a triangle, looks like a right triangle, we are told that we have two angles that are congruent. That makes it an isosceles right triangle. It also tells me that the sides opposite those two angles are congruent. If they're congruent, that means they're the same length, and so we can set their values equal to each other, and we can solve that equation. So the base angles theorem lets me work with equal angles, opposite equal sides. So in this case, 24 is going to equal 3x plus 6. And if I solve that out all the way, I'll get x equals 6. Okay, and so you can try to solve that out to see. But the point of the base angles theorem is that the sides opposite the congruent angles are congruent, or the angles opposite the congruent sides are congruent. Another type of problem that we'll use with the base angles theorem is this, where we have triangles drawn inside of triangles, trying to find values for x and y, and using what we know. And so we can actually spend a couple minutes just doing this problem as an example. We'll start with the sides. And you have some homework problems like this. The two sides that I see that are congruent right away, I've highlighted in yellow. They each have a black tick mark or congruent mark that shows me that this triangle is an isosceles triangle. So if the side that I see is mentioned as 20 on the top of the triangle, then this other side on the bottom left of the triangle will also be 20. That's what I know. I also know that this angle down here is going to be x because this angle up here was equal to x. So I have two sides that are the same, 20 and 20, and two angles that are the same, x and x. I can use the sides because on this bottom I have an equilateral triangle, and so all of the sides are the same. And so that means all of the sides are 20. So 5y can equal 20, and if I divide by 5, then y equals 4. So I figured out that one. The other strategy that I can use that shows up a couple times in the homework is that we can actually create a linear pair. Remember, a linear pair is two angles that are adjacent to each other, and they form a straight angle. And if I have those, then I know that those two add up to 180 degrees. So they're supplementary to each other. We call that a linear pair. That's what's going on right here in the diagram. The angle that I have from the equilateral triangle and the vertex angle of the isosceles triangle form a linear pair. Well, every angle in an equilateral triangle is equal to 60 degrees because 60 times 3 will give you 180. So this part of my linear pair is 60 degrees. So it means that this part of my linear pair has to be 120 degrees because 180 minus 60 gives you 120. So now I have a triangle, kind of messy diagram, a skinny isosceles triangle with a vertex angle of 120 degrees and two base angles both equal to x because they're congruent. I can then use the triangle sum theorem to say 120 plus 2x, x plus x is 2x, 120 plus 2x is equal to 180, and I can solve that equation. Subtract 120 from both sides, 2x is equal to 60, divide by 2 on both sides, and x is equal to 30. So that's a couple of examples of how to use the base angles theorem as it relates to target 5.